Here I'm going to take a look at a couple of multiple choice problems from the first midterm of 2024-25 fall term. So this is the first one. So this is midterm 1, multiple choice 1. Here we have a hot air balloon that's going up vertically at a constant speed of 10 meters per second and is 240 meters above the ground when a key is dropped from the balloon at time t equals 0. Using the coordinate system shown, find the maximum height from the ground reached by the key. So we have some ground, and the coordinate system they give us tells us that this is at 0 and up is positive. Are they calling it x or y? They're calling it y. Okay, plus y. And our balloon starts over here. So this is our y0. Y0 is 240 above the ground. So it's positive because up is positive. And velocity is that this is going up vertically. So v0y is 10 meters per second. This is in meters. This is meters per second. We are using MKS unit system. And we take g to be 10 meters per second square. Okay, instead of the more conventional 9.8. Now, the maximum height from the ground reached by the key. So we drop this here. Of course, the moment we drop the key, it's going to attain the velocity of the balloon, whatever it is, and it's just going to start going up initially. But eventually, it will reach a maximum height and drop down. So it will do this motion. They're asking about this y max. Okay? There are a couple of ways to do this, but I think it's easiest to calculate this distance and just add it to your initial distance to ground, 240 meters. Okay? And how do we calculate this? We've done this numerous times in class. So at the very maximum, that component of the velocity is going to vanish. So you're going vertically. At the maximum point, the vertical component of your velocity is going to vanish. Why? Well, because if it didn't vanish, then you would go a little bit further. And you can also look at the y versus t graph. It's going to pass through a maximum. The slope, which gives the velocity in the y direction, is going to be 0. Right? But knowing this and noticing that we don't actually need the time, we can use the timeless formula. Vy squared is v0y squared plus 2ay delta y. Okay, so Vy squared, we just said that it's 0. At the maximum height, it's going to be 0. V0y squared is, 10 squared. It's going to be. Ay is minus 10. The gravitational acceleration is down. Its magnitude we take to be 10. And delta y is what we are looking for. So this is going to be 100. This moves to the other side, becomes minus 100. This is minus 20. Delta y is minus 100. Divided by minus 20, it's 5. But this delta y is how much you moved from your initial position. So your y final, or y max, in this case, is going to be 240 plus 5, which is 245. Okay? And that will be choice B. Okay. Now let's look at another problem. Here we have two particles. One is thrown vertically downward, one is thrown vertically upward, both from a height of 15 meters at the same time. And when the second particle reaches its maximum height, the first particle hits the ground. And we are asked what initial speed is required for this to happen. So let's, this is the ground. These guys are being thrown from some height of 15 meters. One with some v0 this way, and one with some v0 that way. The magnitudes are the same, but the directions are opposite. Now, there is no coordinate system given here, but I'm going to choose one. I think it's convenient to choose one. Something like this. No, very conventional. Ground is 0, up is positive, something like that. And we want to calculate this v0. Now, in the previous problem, we had this situation there. So this one is going up and then coming down. Well, not really coming down. And this one is going down. So we want to calculate, again, the time from one of them and substitute into the other, something like this. So because we require actually time, we can't use the timeless formula for this one. It will be very convenient, but it will be completely useless. We actually need time. So what we can do for particle 1, sorry, particle 2, that's the one that's thrown up. For particle 2, we can say that, v2y is v2 0, v2 0y, this is getting a bit convoluted, plus 1/2 a, there is no 1/2, just a times delta t. Okay? And this is going to be 0. At the maximum height, the velocity is going to be 0, as in the previous problem. This one is, we chose up as positive, so this is v0. And this is a is just, you know, the acceleration is g, and this is delta t. But from here, I can pull delta t to be minus v0 over a. Okay. Now, for the second particle, I have the height information, so I know how much it gets displaced. So I'm going to use that one. For this one, I have the velocity information, so I use the velocity formula. For the second one, x1 is going to be x10. Why did I say y to this? X1 is going to be x10 plus v10x delta t plus 1/2 a delta t squared. Now a I don't need to worry about because a is just a for both of them. They travel at the same height. So this one, x1 is 0. This one is h. This one, now this one starts with a downward velocity, so it's minus v0. And delta t is something I'm going to substitute from over there. So 0 equals h minus v0. Delta t is minus v0 minus plus v0 over a, and plus 1/2 v0 square over a square. So its square is of course going to be positive. So this is v0 square over a plus 1/2 of that, so it's 3/2. H plus 3/2 v0 square over a, because there's an a here, a square over a, and now v0 square is going to be minus h times 2 divided by 3 times a. So v0 square is going to be minus 2h by 3 times a. Is this right? Sure. Okay. Yeah, it is. It seems that this is the answer. So a here is going to be minus 10. And so you need to take a square root. H is 15, so you can maybe take the square root. So let's plug the numbers in. So minus 2 times 15 times minus 10 makes this plus. Divide by 3, this becomes 5, 10, 10. Oh, v0 is just 10. Okay, and that will be choice B for this one. Okay, let's take a look at another one. I'll just keep going. T equals 0, and then initial velocity v0. Okay, so this is multiple choice 3. v0, our initial velocity is minus 14 I hat minus 8 j hat. It's actually given with 0.0. I'm just not going to write those down. Meters per second. I'm again not going to write those down. The acceleration itself is 7 I hat plus 4 j hat. They're also implicitly giving you the position. Your r0 is 0. You start at the origin. Okay? We have to find the position vector r at the time the object comes to rest momentarily. Now, for the object to come to rest momentarily, both components of velocity has to vanish. Now, if you knew this, if you knew that this actually happens, then you will just use the timeless formula, but you don't know that this happens. You have to somehow justify it. You can say that the ratio of the two components of acceleration is equal to the ratio of the two components of the velocity, and consequently, when they actually are, multiples of each other, when one becomes 0, the other also has to become 0. You could say this, you could write this down, and then use the timeless formula, or you could just do the calculation. Okay? So you can find when this is going to be 0 and you can find when one x component of velocity is going to be 0 and when y component of the velocity is going to be 0, and then calculate r from there. So Vx is V0x plus ax delta t, and likewise Vy is V0y plus ay delta t. So this we require to be 0. This one is minus 14, and ax is 7. This is 7. So this is negative velocity, this is positive acceleration. Yes, at some point it's going to come to 0, but from here we find delta t is just 2 seconds. Okay? And when do these cancel, then delta t is equal to 2. And likewise, this is minus 8, this is 4, and so delta t from here is also 2 seconds. So at 2 seconds, both components of velocity vanish, it comes to a rest. Now at 2 seconds, what will be the positions? Well, x is x0 plus v0x delta t plus 1/2 ax delta t squared, and this is going to be 0 plus v0x delta t is minus 14 times 2 plus 1/2 a delta t squared, so 1/2 7 times 2 squared is 4. 4 times 7 is 28, divided by 2 is 14, minus 14. This is going to be minus 14. And y, if you go through the same algebra, now this is going to be minus 8, this is going to be 4, so you'll get minus 8. Okay, and you write your final position using the unit vectors and the units and everything properly, as the x component is minus 14. Let's put a 0 here for good measure, and then minus 8 meters. Okay. In fact, you don't have to write this carefully because this is a multiple choice problem, and this will be choice E.